of everything they worked out yesterday for us. And now we have to figure out how to put it all in graph. So we know x-intercept and y-intercept are both 0, so that gives us a point on our graph. There's no vertical asymptote here. It was rational, but remember the denominator is an imaginary number that made that 0. Our horizontal asymptote turned out to be at 0, so we'll mark that with a dashed line. Okay, it was increasing from -3 to 3, decreasing elsewhere. Let's plot our max and min, since those give us actual points. Now notice these y values are pretty small, so I'm going to space things out quite a bit on my graph. I'm going to say this is 1. This is -1 to help me here. So we had our min at -3, -1/6. And our max at +3, +1/6. All right. So we know the graph is increasing between those two, so it's going up. Now we don't know the curvature yet. That's where the concavity comes in. Let's mark our inflection points. 0, 0 is an inflection point. How do we show the inflection points on the graph? X's. Okay, so this is going to be an inflection point. These, we have to probably approximate this a little bit. If you did -3 radical 3, let's get our decimal for that. That's at -5.19, so -5.2. The y is negative radical 3 over 12, so -0.14. So fairly close to the 1/6, but not quite there yet. So we'll mark that one with an X, and then we have the positive version. Okay. So now we start drawing our graph. We know it has to be falling. We know that it is curving downward. So my two options in the graph is falling. This would be concave up, this would be concave down. So it's got to be curving downward. We also know at asymptotes we are getting closer to those, right? So it's going to start off like this. Now once I hit that X, we see it's curving upward until I get back to 0. So it's not like it's a drastic change, but it's curving upward. I'm going to start increasing here. Okay, it's still increasing, but I hit my next inflection point, so now it's curving downward. Still curving downward, hit my last inflection point, so curving upward. So we get a graph that looks something like that. Any questions there? Okay. Group number 1. Why don't you guys come up and walk us through this problem? And if you need a recap on the directions, I can tell you what you're finding on each step again, since you don't have the paper in front of you. First step was your domain.
Since our domain is a polynomial, it's just going to be
Just touch the pen. All right, try it now. All right.
Is it now yet?
Here we go.
Alright. Since it's a polynomial, it's just going to be from -infinity to infinity.
Good. And that's true with every polynomial. So if we don't have that rational function, we know it's an automatic.
And then looking for our x and y intercepts. So for our x-intercepts, is already basically set up, like, so we can, what is that, factorizing? So yeah. The radical 3 is basically just disappears since it's over the zero, so then it just x equals
Good.
4.
2 x-intercepts.
And then for our y-intercepts, we're going to do
Y-intercept, where you hit the y-axis, so x is 0.
and then we know since anything times 0 is 0, the solution y equals 0.
Good. Next up, we need asymptotes.
Oh yeah, I didn't know label it.
Okay. And since it's a polynomial, it's not going to have any asymptotes for vertical or horizontal, so.
I should have taken A and C.
Yeah, Hunter got the nice
Yeah.
ones today.
Yeah.
Well, it's actually good because you got D and you did it way better than I did. So.
Alright. Part D,
Alrighty.
increasing, decreasing.
So, first of all, we're going to start off by finding our derivative, which is going to come out to be 3x, x minus 4 to the second.
He's doing the product rule right here, right?
Mm-hmm. This is after I've done the product.
Yep.
This is just. And then I subtracted over my x minus 4 to the third so that it was.
Because for increasing, decreasing, we're setting it equal
Oh,
to
yeah.
0.
Sorry, yeah. And then I took my. And then divided by my x minus 4 to the second. Subtract over our 3x plus negative 4x. Or I guess I probably should just add it over, but just do it the hard way. X is equal 4, or x is equal 1, sorry.
Is that the only critical point?
Someone we found.
I think we might have lost one, and here's why. When you divided by the x minus 4 squared, you made the assumption that that wasn't 0. But could it have been 0?
Yeah.
Yeah. So another option for this would be right here. We have 2 terms. What do both of them have in it? So if we took out x minus 4 squared, that leaves us with 3x plus x minus 4. So then that's 4x minus 4. So if we set each parenthesis equal to 0, we get 4 and 1. So there's actually 2 critical points. Now, is what they did necessarily wrong? No. But you have to remember the derivative, or critical points are anywhere the derivative is 0 or undefined. So if you're going to divide by that, you have to recognize we need to still include that number as one of our critical points. So we would have to put that back in there. So that might change a few things for you moving forward.
Yeah, it will definitely.
Set up your sign line, I'll help you out.
Alrighty.
Okay, on our local max and min. Before this.
Let's finish the increasing, decreasing though.
Oh, don't want to do
Sorry. Yep. Oh, yeah, I didn't mention.
Okay, so then we do our test points. Okay, so if we put in 0, remember we put these into the derivative. You're welcome to just plug them in, maybe right here. That might be the easiest spot when everything is nice and factored. So if we put in a 1 minus 4 is negative, but you square it, it's positive. Or sorry, we're putting in 0. Put in a 0. Negative 4 squared is positive, 0 minus 4 is negative, so a positive and a negative would make negative. If we put in a 2, 2 minus 4 is negative 2, squared is positive. 8 minus 4 is positive, so that's positive. Put in a 5, 5 minus 4 squared is positive, 20 minus 4 is positive, so we get positive. Okay, why did we get 2 positives in a row?
Because that's an asymptote, or
We didn't have any asymptotes on this one. It can happen when something is squared like this. So, increasing, decreasing is probably still going to match what you had written down on your paper.
Mm-hmm.
We are increasing where this is positive, which is,
From 1 to infinity.
we don't have to break it up at 4 because that wasn't an asymptote. If it's a rational one, we would. Decreasing is where it's negative. Which is a negative infinity. So leaving out that critical point actually didn't hurt you too bad. All right, part E, maxes and mins.
I'll find this.
Do you want me to scroll down for you?
Yes, please. I'll keep you teacher's purple.
Okay.
Suits her. So, up here, 1 is going to be our local min, and we're not going to have a local max, or it just keeps going up. So our local min, do I have to show the things?
No.
Okay. So,
How do we get the y value for the local min?
plugging it to the original.
Yes.
Minus E.
All right, so now we need our second derivative. You can do it from what you had, but it might be even easier if you use how we had simplified it. Let's see, so we had our first derivative when we factored it, x minus 4 squared times 4x minus 4. That might be easier to do the second derivative from, just because you're only going to have to do product rule once. But if you did it from the other, that's certainly okay as well. This just might be a little bit easier to factor and simplify at the end, whatever you like. Or do you want me to walk through it since you did it differently?
Yeah, I did a lot of that.
Okay. So we need the second derivative. So product rule, derivative of the first. So do the chain rule within there, the 2 comes down, inside stays the same, subtract 1 from the power. Derivative of the inside is just 1, so that's the derivative of the first piece, times the second one, plus the first, derivative of the second. So what's the derivative of 4x minus 4? All right, 2 terms, what do they both have? So if I take that out, then I have 2 times 4x minus 4 plus 4 times an x minus 4. So this will give me an 8x plus a 4x, so 12x. Negative 8 minus 16 is negative 24. So maybe just a little bit nicer to do it that way, because now we can easily see inflection points. If we set that equal to 0, what do we get?
4, 2.
Okay. Can you do the sine line for our concavity?
Yeah.
Okay.
We got the same ones.
Yeah. We just took the very long time.
Yeah, not that what you did was wrong, it was just uglier, I think.
So for our concavity, 2, 3, 5, and positive, negative, positive. Meaning that we are concave up from negative infinity to 2 and from 4 to infinity. We're concave down from 2 to 4. Want to graph it, Hunter?
Can you give me some
Just a little bit. Okay. So let's start with our graph. And we'll start with any concrete points we have. So we knew our x-intercepts were 0 and 4. So let's put a dot at 0 and 4 on the x-axis. Space out your x a little bit.
how much I should probably space this. Okay. Just take the negatives.
Okay.
0 and 4.
Go ahead and throw a dot at 0 too. So make sure we don't forget it. Good. Y-intercept was 0, so we already have that. No asymptotes. Let's go ahead and plot our local min. 1, negative 27. So maybe count by.
I counted by 3s on here, but
Sure. Now put 1, negative 27.
that is going to be our what?
Our minimum.
Mhm.
Okay. Now, we know our inflection points. We're at 2 and 4. Let's go ahead and get the ordered pairs for those so we can mark those exactly. When you plug a 2 into the original, what do we get out?
Negative 16.
So put an X at 2, negative 16.
By 3s, right? Yes, you did.
Good. And the other one was when X was 4, and if you put 4 into the original, we get 0. So that X-intercept is also an inflection point. Go ahead and throw an X on it so we know it's both. Okay. Now, our graph started out decreasing until we get to our minimum. We know we have to go through those points, and it is curved upward. Okay, so decreasing but curved upward. Looks like a parabola kind of. So can you draw in that part?
I'll try my hardest to.
It's sometimes kind of hard to draw that on there. There you go. Okay, now it switches to increasing and still curved upward until we get to that X. Okay, now it's a subtle change to curving downward until you get to the next X. Good, now it's still increasing but curving upward again. All right, very nice. Any questions for them? Okay. Last one. Group number 2.
So you start with the domain, and since it's divided by x minus 1, you will find when the denominator equals 0, which is just 1. So your domain would be infinity or negative infinity to 1, union 1 to infinity.
Good.
The next one, the asymptotes, right? Is that the
Intercepts is what I had listed next.
intercepts? Okay, yeah, that's right.
So x-intercept.
So to find the x-intercept, you have to set the y equals 0. So 0 equals x minus 1, and then multiply both sides by x minus 1, you just get x equals 0. And y-intercept, it's the same thing, but you set x equals 0, so you get
I did this wrong. I did this wrong.
No, you're doing good.
Am I?
Yeah.
Because it'd be 0 then negative 1, so it's still be 0.
Okay, yeah. Oh, but I have mine. I think I just messed up on the paper. Is the y-intercept 0?
Mm-hmm. Because you have 0
I must have-
divided by
That's
negative
what I
1.
want.
Yeah, I messed up on the paper. Okay, yeah. So you,
Good.
yeah, 0.
So x and y intercepts are both 0. All right, next up we have asymptotes. So vertical asymptote, how do we find it?
So the vertical asymptote would be what was like that?
Do you remember, Cole?
Oh,
Is this
wait,
someone
I
else?
did. Okay, I was looking at the asymptotes. That's the, so we said 1 equals 0.
Uh-huh.
Okay. Which it would still be like negative 1.
So x minus 1 equals 0, so x equals
X equals 1.
1. So that's our vertical asymptote.
And then the horizontal asymptote is when you set the limit as x approaches plus minus infinity x minus 1, and then you multiply the top and bottom by 1 over x, so you get 1 over 1 minus 1 over
And there's
x.
still a limit, right?
Yeah. Which that'll come out to 1 over 0, which would just be 1.
Mhm. So our horizontal is y equals 1. All right. Next up,
Is that the derivative?
yes, we're ready for our increasing, decreasing.
So, F1
So low d high minus high d low over low squared. Good. Critical points are anywhere this is 0 or undefined. Is it ever 0? No. Where is it undefined?
1.
Uh-huh. So our critical point is x equals 1. Good. So doing sign line, remember you plug those test points into your derivative. Both are negative. Can we say it's decreasing negative infinity to infinity? No, because why? There's an asymptote at 1, so we do have to break this one up. Good. All right, so maxes and mins.
X's and M's. So to find out, you would plug in these back into the original.
And we can also look if it goes from decreasing to decreasing. Do we have a max or a min there?
No.
No. Now, we get a max or min when there's a switch between increasing and decreasing.
Mm.
Since there is no switch, we don't have any. If there was one, we plug it into the original to get the y value. So we can just say no max or min. Okay. Now,
I'll just do the second derivative. So then you would just do the low D high and then high D low. which would come out to, this one is squared, 0 minus negative 1, 2, x minus
Good. So you did the chain rule on that one.
1, x minus 1 squared,
Mm-hmm.
which when you multiply that out and simplify it, it just comes out to negative 2 over x minus 1 to the 4.
Almost. Small
Almost.
thing here. You have minus a negative, so it actually turns out to be a positive 2.
Oh.
Do you guys see how we got that? This one turned into 0, multiply those, and then reduce and x minus 1.
Good. I'll set up the sum.
And then yesterday, all right. Let me scroll down for you.
Yeah.
Can we get an actual ordered pair for the inflection point?
Oh, yeah. Or wait, no.
No, because it happens at the word asymptote this time. All right.
Then just the graph.
Mm-hmm. So go ahead, we'll start with x and y intercepts. So both of those were at 0.
Mhm.
We didn't have any maxes or mins to plot. We don't have any inflection points to plot, but we do have asymptotes. So we'll put those in.
0 and is that a 1?
Mhm. Okay, so we know the graph starts off decreasing, so it's falling, and it's
Mhm.
curved downward because concave down. And we know as asymptotes we are approaching them as time goes on. Okay, then the second section, it's still decreasing, but now it's curved upward.
So it'd be down here.
Well, it's got to
Oh.
be falling.
Yeah. So.
Yeah, there you go.
Yeah.
All right. What questions do you guys have? You all did an amazing job. Very nice. Okay,